learning differentiation and integration of power series. Then remember the power series, the summation of Cn, Xn, n equals to 0 to infinity. Then the chain rule applied to a power series, then the function becomes f of x equals c0 plus c1x plus c2x squared to infinity. Properties of functions defined by a power series. Then the function of a power series, f of x equals the sum of an times the quantity of x minus c to the power of n as n equals to 0 to infinity. Then applying chain rule to this power series, it becomes a sub 0 plus a1 times x minus c plus a sub 2 quantity x minus c squared plus a3 quantity x minus c to the power of 3 until infinity. Then, this power series has a radius of convergence of r that is greater than 0. Then, on the interval c minus r and c plus r, f is differentiable and continuous. Here is the derivative and antiderivative of f are as follows. Then remember our power series here. Then f prime evaluated at x equals the sum of n a sub n quantity x minus c to the power of n minus 1 as n equals 1 to infinity. Then this derivative came from our power series, the sum of an quantity x minus c to the power of n as n equals 0 to infinity. Then applying chain rule to this derivative of f, we have a1 plus 2a2 quantity x minus c plus 3a3 quantity x minus c squared until infinity. For number 2, we have the antiderivative or the integral of our power series given here. So we have the integral of fx dx equals c plus the sum of an x minus c to the power of n plus 1 all over n plus 1 as n equals to 0 to infinity. Applying chain rule to this antiderivative of f, we have c plus a sub 0 quantity x minus c plus a1 quantity x minus c squared all over 2 plus a2 quantity x minus c to the power of 3 over 3 until infinity. And for here, we have the intervals of convergence for f of x, f prime evaluated at x, and the integral of fx dx. For example, find the interval of convergence for each of the following. We have a, function of x, b, f prime of x, and c is the derivative of f of x. Considering the function f of x is equal to the sum of x to the power of n over n factorial as n equals to 1 to infinity. We have here, for a, we have function of x. Function of x, the given, we have the sum of x to the power of n over n factorial as n equals to 1 to infinity. Then first, we'll find the limit of our given function. So we have limit as n approaches to 0. And for the limit, we are going to add 1 from the given n variable. So we have x to the power of n plus 1 over n plus 1 factorial. Then we will divide the given function for the limit. We have over x to the power of n over n factorial, then absolute value. Because the limit as n approaches to 0, the absolute value of, we have x to the power of n. Since x n plus 1, then applying product rule of exponent, we have x to the power of n times x to the power of 1 over n plus 1 times n factorial. This came from n plus 1 factorial times the given function, then we'll take its reciprocal. We have n factorial over x to the power of n. Therefore, here we can cancel out same factors, x to the power of n and x to the power of n in the denominator. So we also have n factorial from the numerator and n factorial from the denominator. And the remaining variables are x over n plus 1, or the absolute value of x over n plus 1. Then this will also equal to 1 over n plus 1 absolute value times the absolute value of x. Then 1 over n plus 1 is also equivalent to 1 absolute value times absolute value of x. We have absolute value of x, which is less than to 1, and we'll find its interval of convergence. We have -1 less than to x and less than to 1. So we have x equals to 0. We have here x is greater than -1 but less than 1. Apply x 0. We will add. We have 0 and 0. -1 plus 0, we have -1. And 1 plus 0, we have 1. So our interval of convergence for a, the function of x, we have -1 and 1. And for letter B, we're able to evaluate the derivative of f evaluated at x. Then we'll remember our given. We have f of x equals to the sum of x to the power of n over n factorial, as n equals to 1 till infinity. Then the derivative of this given function. Then remember the derivative, we will able to make the exponent as our coefficient and subtract -1 from the exponent. So we have f prime of x equals the sum of n x to the power of n minus 1 all over n factorial, as n equals to 1 to infinity. Then we'll evaluate its limit. So we have limit of n as approaches to 0. We have n plus 1 because we will add 1 to all values of n, to all variable n. N plus 1 times x to the power of n plus 1 minus 1 over n plus 1 factorial over n x to the power of n minus 1 over n factorial, the absolute value. Then equals the limit as n approaches to 0, the absolute value of n plus 1 x to the power of n. It becomes x to the power of n since 1 minus 1 equals to 0. Then over n plus 1 factorial, then we will factor. We have n plus 1 times n factorial times the reciprocal of our given derivative of a function of x. We have n factorial all over n x to the power of n x to the power of -1. So we will cancel out same factors. So we have n plus 1, we'll cancel n plus 1 here, and x to the power of n, x to the power of n factorial, and n factorial. Then the remaining variables, we have 1 over x to the power of -1. Then we will take the reciprocal of x to the power of 1. It becomes x absolute value over n, because we will have n here. Then we have the absolute value of x over n. This will also equals to 1 over n times x, or 1 times x. Here the absolute value of x less than 1. Then x equals to 0, -1 here. So we have x greater than -1 but less than 1. Then we'll add 0 to both values of c minus r and c plus r. So add 0 here. So we have -1 plus 0, we have -1, and 1 plus 0 is 1. So our interval of convergence is -1 and 1. And here for letter C, we will take the antiderivative or the integral of our given function. The sum of x to the power of n over n factorial as n equals to 1 until infinity. So we have here the integral of our given function. We have the sum of x to the power of n plus 1 over n plus 1 times n factorial as n equals to 1 until infinity. Then we will evaluate our limit here. We have limit as n approaches to 0, the absolute value of x to the power of n plus 1 plus 1 over n plus 1 plus 1, the quantity of n plus 1 factorial over our given antiderivative. We have x to the power of n plus 1 over the quantity of n plus 1 times n factorial equals limit as n approaches to 0, the absolute value. Then we'll factor this. We have x to the power of n times x to the power of 1 times x to the power of 1. And our denominator, we have n plus 2. N plus 1 plus 1 equals n plus 2. And we'll factor our n plus 1 factorial here. We have n plus 1 times n factorial times the reciprocal of our given antiderivative. We have the quantity of n plus 1 times n factorial over x to the power of n times x to the power of 1. Then we'll cancel out the same factors. We have x to the power of n, x to the power of 1, n plus 1, and n factorial. Then we have x over n plus 2, the absolute value, equals the absolute value of 1 over n plus 2 times x. Then 1 over n plus 2 is equivalent to the absolute value of 1 is equals to 1 times the absolute value of x. Then the absolute value of x is less than 1. Then we have here x equals 0 and x which is greater than negative 1 and less than 1. Then add 0 to c minus r and c plus r, 0 and 0. We have negative 1 plus 0, negative 1, and 1 plus 0 is 1. We have our interval of convergence, negative 1 and 1. At this point, we'll find its endpoints. And for the endpoints, you're going to substitute your intervals negative 1 and 1 from the given function f of x equals to the sum of x to the power of n over n factorial as n equals to 1 until infinity. After substituting the interval of convergence negative 1 to 1 from this given function, it has found out that the function is convergent at negative 1 and divergent at 1. And for number 2, after evaluating its endpoints of f prime of x, the sum of n x to the power of n minus 1 over n factorial as n equals to 1 until infinity, it has found out that the function is convergent at negative 1 and diverges at 1, given radius equals to 1. And for number 3, the antiderivative of the given function, the sum of x to the power of n plus 1 over n plus 1 times n factorial as n equals to 1 until infinity. After evaluating its endpoints, it has found out that the function converges at negative 1 and diverges at 1 given the radius equals 1.